This note is about types of functions. During this course, we are going to be talking about the following 4 functions. 2 of them you will recognize, linear and quadratic, and 2 you've probably maybe seen but not really talked about, the exponential and the periodic. So looking at this first graph, the linear function, I know that this is linear because it is a straight line. I know a couple of other things about linear functions. I know that they're in the form y equals mx plus b. I hope by now that's been drilled into your head, and as soon as you see something that's in that form, you recognize that that does represent a linear function. This particular linear function is positive, so it's increasing as we move from left to right. But I can have a negative linear function, and I'll just quickly draw you. That would look like this. So as I start from the left and move right, this function is decreasing. Just a little quick blurb about this quadratic. We know that typically quadratics involve an x squared. And I know that, again, this one is positive because I like to call it a happy face. But I can also have a negative quadratic, and that would be a sad face. So a couple of things happen. When we have a quadratic, instead of just increasing or instead of just decreasing, we have this function that's going down and then going back up. I'll just highlight that here for you. Or if we are looking at this -1, it goes up and then back down. Now, one cool thing about these quadratic functions is that they're always symmetrical. The third function that we're going to be talking about is the exponential function. So exponential functions can be 2 different kinds again. So this one represents an exponential growth. So something starts off growing slowly, but as you go, it grows quicker and quicker. Some examples of this would be money in a bank account, or bacteria growing if you're thinking about biology. And again, we could have exponential decay. So this is the exact opposite. It starts off really high and it drops really fast and then slows down as time goes on. So an example of this would be depreciation in cars, sometimes temperatures, depending on what we're talking about. And the third function is a periodic function. This is going to be the newest type of function for all of you. You've probably not seen it, especially since most of you didn't take physics, although some of you will have seen this in sine waves or sound waves or anything like that. A periodic function is basically like a whole bunch of quadratic functions, one after the other. So they increase, decrease, increase, decrease, and they follow the exact same motion as they go. In grade 9, you probably did quite a few of these story graphs. They were a pretty big part of the EQAO, and you did talk about them a lot when you were in your linear, I guess, unit. So here I have a story graph for you. On the bottom, or the x-axis, this represents time in hours, and the y-axis represents distance in kilometers. So the first thing that I'm going to talk about is what's going on here. So when I look at this, I do see a linear function followed by a horizontal function, another linear function, a horizontal function, and this like decreasing exponential decay. Now, the title of this is about taking a hike. So we're going to assume that somebody is taking a hike. If I look at the time, it's a 5-hour hike, which is a really long hike for me. And this distance in kilometers is going to represent how far they've been after a certain amount of time. So consider, what does it mean when the graph goes up? So we're looking at this first section right here, or even this third section right here. Maybe I'll label them for you. So section 1, 2, 3, 4, 5. So in section 1 and section 3, I know that this graph is increasing. And so what it means is that in this 1 hour, I can see it's increasing up until 1 hour. This person has walked or ran, whatever, hiked a total of 4 kilometers. So I can see they're hiking at a steady pace because this is a linear function. Now that happens again in this third section. So from 1.5 hours all the way up until almost 3 hours, this is another positive linear function. So they are hiking again at a steady speed. This is not as steep of a line as this first section, so I do know that they're hiking at a slower speed than before, but it's still increasing at the exact same amount every time, so it's still steady. What does it mean when the graph is flat? So I can see that my graph is flat here in section 2 and here in section 4. So if I think about what's happening here, from 1 hour till 1.5 hours, this person still stayed at 4 kilometers the entire time. So what we know about this little section right here is that they took a half an hour break. They sat still, they didn't go any further, and they just relaxed. The exact same thing happened here in section 4. So from 2 hours and 45 minutes all the way up until 3.5 hours, they didn't move. So they stayed at 5.5 kilometers. So they took another break in section 4. So I'll just write here so you remember section 2 and section 4. What does it mean when the graph is curved? So here I have this curved part of the function. Now you're going to notice this is the only section of the graph that is going down. So we can assume that this whole time this person was hiking further away. The furthest they got from us was 5.5 kilometers. And then at the 3.5 hour mark, they started hiking back towards where they started. And that was up until the graph ended at the 5 hour mark. So this part of the curve is very steep, and as it gets further and further closer to 5, they slow down. It's less steep. So this person started hiking back pretty fast, and they slowed down as time went on. One can only assume it's because they got tired. So this would be section 5 of the graph. What you are going to do now is go back to our Brightspace page and take a look at a Desmos link that I gave you. You're going to go through a Desmos activity where you're going to be trying to draw some of your own sketches based on stories and trying to match up some graphs. And so it's just a great way to practice everything that I've talked about here.